this is Britt Caswell with another example video. In today's video I'm covering example 4 from section 6-5 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to apply the properties of logarithms. So our word problem here, it says that the pH of a solution is a measure of its concentration of hydrogen ions. So when we're talking about pH, we're usually talking about like the acidity of it, okay? This concentration, measured in moles per liter, is written as H+. And it's given by this formula. So what they want us to do is they want us to use that knowledge in order to determine some acidity levels for a few items. So this one says, what is the concentration of hydrogen ions in the acid Rainfall? Okay, so acid rain, right, it comes from pollution. And we're being told that it has a pH of 4.5. So I'm going to take 4.5 and plug it into the formula where it says pH. Alright, so now that I've plugged it into the formula, now I need to go about solving for the H+ here, okay, which is the concentration. So the first thing that we need to remember here is when I have an expression like this within the logarithm, I usually don't like having my variable that I'm solving for in the denominator of a logarithm. So what I'm going to do is I'm going to use our quotient property to split this logarithm into two logs. Now remember, the top of the fraction goes with the first log, and then I'm subtracting the log with the bottom of the fraction in it. Now here, a log of 1, if ever you get a 1 inside of a logarithm, that cancels out as a 0. So really this expression says 4.5 equals the negative log of our concentration. And to get rid of the log, I have to take this negative away, so I'm actually going to divide by -1. Really all that does is that moves the negative sign to the other side of the equal sign. And to undo a logarithm, remember you have to exponentiate. So I'm going to raise both sides of the equation to the same base. Now remember, whenever I do this, I have to make sure that the base that I choose to raise it to matches the base of the log. So in this formula, it's a common log, and so I raised it to base 10. So I get that 10 to the negative 4.5 is equal to our H+ concentration. So if I were to actually plug that into a calculator, I would say that my concentration is approximately 0.00000316 moles per liter. So now I'm going to go through and I'm going to do that same thing, but I'm going to do it with the orange juice. Alright, so again I replace the pH. I'm going to actually change colors on this one. So I'm going to replace the pH with the number 3. So I get that 3 is equal to the log of 1 over H+. Alright, then I'm going to split apart my logarithm. So I get the log of 1 minus the log of H+. Now the log of 1 is 0, so that cancels out. So I get 3 equals the negative log of H+. I divide my negative over. And then to get rid of my logarithm, I'm raising both sides of the equations to be exponents for base 10. So I have that 10 to the negative third is equal to our concentration. Another way to write that, 10 to the negative third, is 0.001. moles per liter. That says liter, I just can't write very well. But there we have it, guys. That's how to apply the logarithms, or properties of logarithms, to chemistry. Until next time.